What gets really interesting, and this is something most scientists don't even know about yet, is level 3, the deep layer of aging. There's actually a DNA clock that tells our bodies how old we are. I could take your blood and read it, and I could tell you roughly when you're going to die.
Talk to me about this notion of resetting the biological clock. How do we do that? What's the mechanism? And so obviously going hungry occasionally, exercise is going to help, but I know that you have a regimen that I'll lovingly call a regimen of drugs or precursors to things that we can take. What can we do to reset that biological clock?
Well, there are different levels to resetting aging. There are 3 levels that we know of. The first is pretty easy to reset or to manipulate. These are the proteins that turn genes on and off very quickly. We call them transcription factors. And they basically read a gene and make a protein. That's what they do. That's level 1. That's easy. Go a little bit hungry, that'll change. Level 2 is a little bit harder. The level 2 is not just changing which genes are quickly turned on and off, but actually silencing genes for a long time. And this is where my enzymes that we work on, the sirtuins, come into play. Let's go back to the Pac-Man. They clip off acetyls off these packing proteins. You spool up the hose, and it becomes locked in. That gene gets silenced for a long time. So to do that, you can exercise, you can diet, but you also, I think, you need a little bit of help as well. What gets really interesting, and this is something most scientists don't even know about yet, is level 3, the deep layer of aging. There's actually a DNA clock that tells our bodies how old we are. I could take your blood and read it, and I could tell you roughly when you're going to die.
What?
Yeah, we can do that.
What are you looking for?
We're looking for chemical groups that get added and subtracted to our DNA, the long string in the cell. You get chemical modifications in predictable ways as you get older, starting from conception. So even in the womb, even as a kid, even as a teenager, you're aging based on this clock that goes up linearly. And where you fit on that line, it's very accurate. That tells you your biological age.
But how do you know when the person's going to die? Is that just based on
draw a straight line.
tables? Is it actuarial tables? Oh, the average human lifespan is 86, and is that what you mean? Or could you see something specific in my line that would say, ooh, you're headed for 68, sorry?
No, it's not specific, but what it's based on is machine learning based on thousands of people's code of methylation on the genome, and comparing that to their health and their date of death.
Oh, fuck, that's so interesting. So if you were to take my blood right now, what would you look for exactly?
We would read the methylation. These are chemicals, hydrogen and oxygen, bound to the DNA, chemically, physically bound. And those accumulate as you get older in very predictable ways. In fact, they're so predictable that we can use the same clock to measure a dog's age and a human's age.